Yeah, we're live. Excuse me. 6:32. I'm a little early, but I was excited because I posted both of the videos today. Boom, 1, 2. Didn't even get people time really to ask me, well, where's the other video? No, they went up. Boom, boom, right at one, right after the other. Just because they're like 50 plus minutes, I think, long. I didn't want to have a 2-hour kind of thing, and I think two videos kind of works for that. So hopefully that'll all work out. And then if you watch the first one, that'll give you incentive, obviously, to watch the second one. So what I want to do is talk a little bit about what some behind the scenes things, mostly because I get lots of comments and questions about stuff that happened or things that they wanted to see or didn't see. So one of the things, obviously, is I did put up the cam specs, the Steve Morris, and he said he was going to do this when I was there. He goes, well, what we'll do, he said, I'll just tell them if they want the cam specs, they'll have to go watch your video. So, okay, that's kind of nice. Throw me a bone there. But Steve's cam that he had that ran in this LS3 was 620 lift. It was a 223, 248 split. It's a pretty big split. 25 degrees is a lot. And then a 115 LSA. So as a 223, not tremendously big in terms of camshafts. Could certainly fit a lot more camshaft in there. And then, if you wanted to make more power, I think and his thing wasn't that he wasn't trying to make lots of power. A lot of guys have a hard time understanding this. And I think maybe more so on his end, given the kinds of motors that he builds and things that he does. But they just can't understand that you put a motor together, and especially something that you're going to dyno, that you're not trying to make as much power as possible. Well, obviously we weren't doing that. I mean, it was a stock bottom end with ring gap, and I love the fact that he put ring gap in it, because if you're going to run boost and you're going to prep it for that, you definitely do that. He put head studs in it, still had the factory head gaskets on it. They did do copper coat on it when they put it back together, because they obviously took it apart to put ring gap in it, and they know a thing or two about putting motors together. They ran it with a stock 821 heads. They did do a valve train upgrade in addition to the camshaft. Pretty sure they did push rods. They did also rockers, and then, like I said, they did head studs on it, which is a good idea. We weren't making really enough power, I don't think. I definitely would have put head studs at 1,000 plus horsepower, and that's kind of where we were going. We talked about this ahead of time, and I said, well, we should do. It would be cool to do it, because we're going to do a Vortec. I said, well, let's just test the heads both ways. Let's test it NA and boosted, and then knowing that it's going to be an LS3, know it's going to be a cammed LS3, know it's going to have airflow research heads on eventually. That we were talking about. I didn't know at the time what intake manifold he was going to run on there. The one that he ran on there is really nice. Definitely chock full of ability goodness, and priced accordingly. Probably was that intake setup probably as much as the rest of the motor. so if you're thinking about that, it's a way to go. But the thing that is cool about it, or something that helped us, is that it's not a really big camshaft at 223, but it's a very short runner intake, 4 to 4.5 inches. And it has lots of cylinder head. Either the stock heads can support a lot of power, the 821 heads, certainly the 380 plus CFM airflow research 275 heads support even more power. But we had a motor, enough motor, enough displacement, enough compression, lots of cylinder head flow, a camshaft, enough camshaft, a short runner intake. And then when we teamed that with a centrifugal supercharger that just continues to make power as we go up in RPM, obviously good things happen. We weren't doing the most power kind of thing. There's certainly more camshaft that could have been had in there. There was another 15 or 20,000 RPM of blower speed available from where we were to where their suggested maximum RPM is. So that's a lot more blower flow at that power level. So we could have run a lot more power. The intercooler was good. The fueling was good. Obviously, Steve knew more than what he needed to know about doing the tuning. In fact, he got very, very aggressive on the tuning, and those were some of the concerns. Like, how can you run that much timing and also the air fuel. Well, and we'll take a look at these things one at a time. The air fuel, I think, was not. I don't think that this motor runs best at 13-to-1 or 13-2 or 13-4 or whatever the commanded air fuel was. I think that the air fuel meter was wrong, and I think that we were seeing a much richer mixture, more in line with what we would normally see in 11s or 12s. I think that's what it was. And judging by looking at the plugs, we see that, and also judging by seeing the exhaust, which you could see, you could see light black when the thing was right and stuff. So the air fuel meter wasn't right. And so that goes to show you that if you just rely on one thing, that you can still be wrong, even if we're looking at an O2 sensor, which is a little scary because I like to rely on O2 sensors. But he was also relying on NOx sensors, which are good, a really good thing to have. And then but most people seem to be concerned about the timing. And I was one of them. I'm like, you're going to run this much timing? Like the NA stuff's not a problem. The air is cold, it's getting good. The water's cold. It's getting, plenty of airflow and stuff coming into the dyno cell. So I wasn't concerned at all. But under boost, particularly on pump gas, he was running what I thought were fairly aggressive timing curves. And the reason that you can get away with that, there's a number of reasons. One is we weren't running a lot of boost. We were running 10, 11 pounds. We were running, another thing, we were running a centrifugal supercharger, which we didn't have 10 or 11 pounds, like lower in the RPM range, where detonation would be much more likely to happen than at the top of the rev range. Because when you have a rising boost curve there, it's a lot easier on things and less detonation. The thing that adds detonation possibility to this is on any sort of supercharger, the power that we're seeing, like 1,000 horsepower, whatever, it's making more than that. It's just that some of that is being absorbed by driving that supercharger. So it might be another 100 or 150 or whatever the number is. So you're actually making that. It just takes some of that to drive the blower. So instead of it being 1,000 horsepower, let's say it's an 1,100 or 1,150 horsepower motor. And so with that attending detonation threshold. But again, cold water, cold air, and good intercooler, a good blower working in its fairly efficient range. We were running 93 octane. Steve has a lot of experience with testing this stuff. The other thing, and I think the thing that's not pointed out enough, is the acceleration rate of the dyno. I think that's why that this amount of timing that I don't normally see when we run on the dyno at West Tech or other dynos that we run, where we're running like 300 RPM per second, that's much slower. And so there's more time for detonation to happen. Essentially, I think that the load is greater. So this thing rips through the run really quickly. And so there's less time and there's kind of less load on it. So I think that that's probably why, if you slowed that down to 300 RPM per second, I don't think you get away with that. We don't ever do that. We don't ever run that kind of timing, not just because I don't think it'll work, but the dyno and the motor, the results on the dyno and the motor tell us that it doesn't like that. It gets to a point where there's no more power gain. And then if you can get to that point where there's no more power gain, the next thing that happens after that is bad. It's gaining power, then it's not gaining power, and then it's like chucking parts out. And so, and it takes on one detonation cycle, you can certainly break a piston or a ring or something. It had ring gap in it, so that you're not going to butt them together from temperature. But breaking a ringland from detonation or something is not going to be obviously not good, and it would have hurt all of the testing that we were doing, because if it would have happened right in the middle of stuff, then we would have been left with nothing, no results, because we did a lot of testing with the stock head and then a lot of testing with the AFR head. And then along the way, because we're dyno guys and we're there, and this is what you do while you're there, you test other things. So we were really there to test the airflow research heads, but we had a motor on the dyno, so why not run pump gas versus E85? Why not test it at NA and boosted? And then we tested the radius air horn NA, and then we put the radius air horn with a little entry, an angled entry on the blower at the end. Although, in looking at the results on that, where we made 1,050, the reason that it made 1,050 is that we ran it at a higher RPM. Now, it did pick up power even at the same RPM that we had been running before on the previous run, but it still made the big number at the higher engine speed because it has a rising boost curve and a rising power curve. And it was still going even there. Had you run it, I joke to Steve, just run it to 9,500. It will just keep making power. And given the fact that we had that much more RPM available to us, with the supercharger being still efficient, if the motor wouldn't have survived that, obviously, but the blower would have had more to give and could have continued to rise given that very, very short intake runner. Now it's only a 223 cam, so we may have run to a ceiling where it leveled off and didn't continue to climb like that. That's certainly possible. But man, we had full NA timing on this thing, especially on pump gas. In fact, we went to 31 degrees. Now, Steve said that he got a detonation event at the top of the RPM range, which I find strange. I'd like to ask him more about that. That's not normally where detonation happens. Detonation usually happens at the torque peak. So unless we had the torque peak at 76 or 7,700 where he's saying that happened, I don't think, and we had it on E85. And so since we already run a lot of timing on pump gas, we weren't that far ahead on timing with the E85. Certainly what in a range that we have run previously, but at lower levels. The difference though, the E85 has a lot more going for it. It has a lot more octane. It has, from the alcohol, has charge cooling. It's just a better thing all the way around. And usually you can get away with a lot more timing. I was surprised, and I'm sure as a lot of guys were, Steve definitely was, that we didn't get like immediate gains from E85. Now, he says he sees them all the time, and I see them all the time. We don't see them a lot sometimes on NA motors, and that's not surprising because there's not enough compression and there's just not enough motor there to take advantage of that. And again, I think that I would point toward the acceleration rate for that not happening. I don't know what else to look at because every supercharged and turbocharged combination, whether it's a blow through kind of thing or a draw through kind of thing, every one of them has added power going from pump gas to E85. Now, I don't know if it's because we already had 29 degrees of timing in it on the pump gas, and so we just didn't have any room. But whenever I do the test, I always just add the E85 and keep the timing there where it was, whatever it was when we were running pump gas, and then find out what that is. And there's almost always a gain. And then there's, there could be more of a gain by adding another couple of degrees of timing. And then with the turbo thing, we can add more boost and go up that direction too, that it allows us to go in. But I always just add the E85 and see what happens. And whenever we do that on a 671 blower or any of these things, a centrifugal blower, Vortec, Paxton, whatever, ProCharger, Torque Storm, Rotrex, whatever, pick your poison. In any of those things, we add E85, it definitely makes more power. And it just didn't this time. I mean, it made a little bit more, but not what we were expecting. Normally, it's like a 30 or 40 hit, and you're like, oh yeah, we're king of the roads now. And it just didn't do that. And I'm actually kind of surprised that it didn't do that. We were able to creep up on by adding more timing and adding more RPM, just the same things that you always do. The radius air horn did improve things by about a half a pound, even in the same range. Now, when you're dealing with a centrifugal supercharger and you get a gain in boost, you don't get the same gain everywhere. When you get a gain like that, it's like doing a throttle body where you gain nothing down here, and then the gain gets more and more and more and more and more as you go out. And that's exactly what happened. That's what I've come to expect, having tested it, I don't know, umpteen times, whatever that is. But the gain that you get, like the half pound that we were talking about, was in the range where we were running it before. And had we run it out further, it may have been a little bit more. There was a difference in the boost readings for the Holley and for the dyno. Again, Steve's run across that for, and we have run across that at West Tech and stuff. Difference between those. Also a difference between the TAC readings on the Holley and on the dyno. And again, at West Tech, exactly the same thing. The Holley reads higher. And I don't know if it's reading accurate. The dyno's not reading accurate. I don't know which one is which, but when we rev it, like we set our dyno to go from 3,000 to 6,500, the Holley is going to show 200 RPM higher than that. It's 6,700. Like, okay. It's a little, especially when you're getting up what you think are near the limits of stuff. Like we ran, that thing went to 8,000, according to the Holley. And so it definitely revved up there, but it was a cool deal. It was great to go back there. I'd like to go back, and maybe I'll reach out to Tom Nelson and see about going to see him. Definitely going to go see Brian Tooley. You know, I love going back there and see those guys, and just kind of do some of this stuff. I thought it was awesome, and I like the dyno sessions, and I like the dyno guys. I need to go down and see Evan now Evan Perkins now is in charge of West Tech. He's running the show there, so I'll hopefully get to go down and do some testing with him. It will be awesome. So let's see what you guys got going on. Lunchbox, what's going on? Awesome video. Thank you very much. We're watching part 2 until it's popped up. I'll finish part 2 and it's over. How does the huge 25-degree cam split help a boosted motor? Did you see what it did? That's why we test stuff. It's a beautiful intake that Steve makes. Yeah, it really is. I mean, when I saw that, I looked at the intake and then also the like Billet goodness valve covers too. I'm like, wow, that thing looks really, really nice. And I think that the motor is going to be for sale. I think that he put that stuff on there, and they're going to take it to maybe Bo SEMA and PRI. I think. I'm surprised. Somebody probably will snatch that up, but it'll be somebody that has money, because, you know, that like I said, that manifold probably is, I think, costs as much as the crate motor does, and crate motors are not cheap. Richard, what layer head gasket do you recommend for an LS boosted engine? I don't really do that by layers. We've run the Felpro stuff. I look at the various thicknesses of them depending on what I'm trying to do. Mostly we go with a 53. We've also run 41s on some stuff, depending on where the piston is, whether it's in the hole and stuff. Or we, like on the Big Bang stuff, we've run LS9 gaskets, even on 5.3s, or on smaller bore motors, even though that was designed for a bigger bore, but it's worked fine. The head gasket, for me, in the stuff that we've done on the dyno, the head gasket isn't the issue. You don't break a head gasket because the head gasket doesn't have enough strength. You would lose seal for some other reason, usually because you detonated and it broke something. If you lift a head, it's because you had too much timing or instantaneous cylinder pressure, that kind of thing. It's not because you've distorted the multi-layer steel gasket. That's just not happening. You prefer Lobach truck cam or truck plus cam for a naturally aspirated engine in a Gen 3? The reason that you're giving after which cam I would pick has nothing to do with which one of those cams I would pick. I would decide on which one of those cams based on, if you go to the store, go to RICHARDHOLDENERPERFORMANCE.com, look at the power curves, and then look where you want your power production to be. That's basically what you're choosing. Do you want more power below 5,000? Do you want more power above 5,000? And then are you willing to do the trade-offs on either one of those? That's why we have the power curves there, so you can kind of select that. Can't believe Steve isn't doing steady state tuning. I thought his level of engine development would be more precise with tuning. Yeah, I don't think I would put somebody as successful as him down like it kind of sounds like you're doing, like you're throwing shade there. He knows how to make power, and he also knows how to make power going down the track, because he's obviously put all of those together and gone very fast. So holding my breath when Steve ran 13.0 with boost and a lot of timing. Yeah, again, like I said, I don't think it was actually 13.0, because I don't think a motor wants that. So it was richer than that. And Steve even said, it's definitely richer than this. I like the fact that he went over the plugs and talked a little bit about that, and that we took the time to go do that so that you could compare that to what you're seeing on the airfill meter and what we're visually seeing. I saw the exhaust like backfeed into the dyno more so when I was watching my screen on my phone when I was filming. And so I could see it in there. I'm like, oh, okay. And I didn't really notice it when I'm not looking through that. I don't know if the camera was catching something that I wasn't catching, but that was definitely a thing. And he pointed that out. Building a 306 small block Ford for my Fox. I have a Comp XE274 cam and a Holley intake. Okay. I'm looking for SVE set 170 heads and the AFR 185 heads. Looking to spend $1,500. I don't know anything about the SVE heads. I have had guys ask me about those, but I don't ever remember testing them. I can say with certainty that you're not going to be using all of probably what either one of those heads are capable of. Certainly not a 185 airflow. I mean, an enforcer head's not going to be as good as the CNC one, but I'm still betting that a 185 enforcer head is still like a 500 horsepower cylinder head, and you're not going to be doing that with a 306 with that camshaft in it. Local machine shops don't have a torque plate for my Ford 300. How important is a torque plate for boring? How important is a torque plate? Could 10 be taken out by honing rather than boring? I don't think you'd want to take out 10,000s. You're gonna want to bore it and then finish hone it. Sure, you didn't sneak some forged internals that engine before you showed up? No, because we took the heads off and checked the pistons. They were factory pistons. My thing's creeping on me. Are you going to do some more testing with the Rotrex? We have it and can do more testing with it. They sent some other pulleys in a different kind of, like a different kind of lower mount, because the lower mount was really close to, I think, something on the steering, if I remember Jimmy telling me correct. Crank the boost. I'm about to finish. Yeah, the nice thing is we never touch the one thing I think Steve showed in his video that I didn't show in mine is there was at the very beginning when we first put the belt on with the pulley arrangements the way that it was, the belt wasn't touching when they first put it on there, but as whenever you run a brand new belt, they stretch, and then the pulleys came and contacted each other. The belt didn't touch itself because of the gates. I just call them gates around the outer edges of the pulleys. And so those kind of stood off and those came together and rubbed a little bit. And so they reconfigured a different mount for where an idler was or something. And then they were able to get it. And then after that, it was just like, just put the belt on. And we never, and in looking at the boost curve, it was nice and steady and perfectly repeatable and stuff, which is nice, which is one of the things that happens when you're running blowers, because it can be blowers, especially with serpentine setups, can be problematic with belt slippage. You don't want that to be happening. And it's not uncommon. And it gets harder and harder to cure the faster and faster you're trying to spin the blower. So it's better to go up in crank pulley size if you can, as long as you're not connected to the other things. Then you're overspeeding the alternator, certainly the water pump, the power steering, all that. But if it's just a dedicated pulley setup, going bigger on the crank pulley is nice because you have more belt wrap rather than less if you go small on the blower pulley. So that becomes problematic. So you want to have a big enough blower pulley on it and a big enough crank pulley on it where you have enough belt wrap, you have enough contact area that helps eliminate slip, and then you don't have the issue. But you start running into that issue when you're getting up near the flow limits of these blowers, because you're working with a combination of, speed, pulley speed, and engine speed, and flow rate. So basically resistance to this thing spinning. It's having to do work because it's processing more air. So there's more load and more RPM. So it just makes life harder on this drive setup. If you have a cog, then you just solve all the problems. But with serpentine setups, it can be kind of an issue. Steve, act like he didn't agree with you saying if it makes, let's say, 300 on pump gas, and when you add, it would double and make 600. That wasn't a pump gas related thing, but that was a boost thing. And it doesn't matter to me that people agree with that. It is true. Not with a centrifugal supercharger, or a lot of times not with superchargers, because they have losses associated with driving the blowers. But when you add 14.7 pounds of boost from a turbo and you have everything right, it usually doubles the power output, and it can do more than that. Sometimes it's a little bit less, but it doubles that. And I would really like to see some of his data on some of these really high horsepower deals, because I would like to see if he's doing things to the motor that make it conducive to do better than that formula. Because like, is he making these big motors that he has have to be super powerful. And then if you make 1,000 horsepower motor and then you add 45 pounds of boost, it's going to make you all of a sudden you're talking about several thousand horsepower. But I'd like to see that. I'd like to see if he has some where the NA thing isn't doing that. And also, and I've made this very clear in all this discussion, that I don't deal with pro mod level of motors. That's not what I'm talking about. I'm talking about the average guy that goes and gets a wrecking yard motor, whether it's a Ford, Chevy, Dodge, a 4200 like Calvin does. Shout out to Calvin, his dad out there. These normal kinds of motors, that formula is really, really good. I don't, not thinking that it's an absolute, even though it is the patented Holdener power boost formula. I'm not thinking that it's absolute. And like we saw there, if I told somebody, hey, look, you absolutely cannot run NA timing on a boosted motor. Well, you can now because he did it. We couldn't have done it or wouldn't have done it at Westech with our acceleration rate and stuff, because it wouldn't have wanted that. It wouldn't have wanted to make that power. But that's not the same thing as saying that you can't do that. He just showed that you can. So when he's saying he's a big proponent, he thinks guys are not running enough timing, that really is a thing, not because he can't come to Westech and run more timing and be successful with that, because the acceleration rate is different. But what he can be is very successful in adding more timing on things like drag race cars that are probably a lot closer to the acceleration rate that he sees on his dyno in each one of the gears. So if you're like first gear, second gear, third gear, I mean, how many seconds or whatever is it in that gear? I mean, and how quickly is it going from 5,000 to 8,000 or whatever? I mean, it's really fast. And so that acceleration rate, you can put a lot of timing in it. You wouldn't be as effective running the kind of timing that we run on a 300 RPM acceleration rate in a drag race car, because it's accelerating a lot faster than that. It will tolerate, and probably a better word is, it will benefit from having more timing in it at that rate of acceleration. Now, it probably would be different in each successive gear as that acceleration rate slows down. I don't know how much it is going to slow down, because I don't have the data in front of me to say that if we can't put all the power down in first gear, maybe it accelerates better in second gear. I'd like to see what the rate is and how much time is spent there. But you could get a good idea from all the data logging, and that's something that he's really good at. He's taken all that data and said, hey, look, on these applications, running this thing at this temperature when we're running at the drag strip compared to what it's doing at the motor, it's doing that. These two things are working out good. And that's the kind of data you need. When guys say that, hey, but the engine dynos are not real world. Well, they are. But you have to go from the engine dyno to a chassis dyno to the street to the track. You got to correlate all that stuff. And that's what he's doing, and which works out pretty well. BTR stage 3. Scrolling. V2 cam and a Gen 3 4.8. What are your thoughts? What are you trying to achieve? A stage 3 cam in a 4.8 is a big cam. So it's going to be soft down low. So what are you trying to get done here? Are you wanting to rev the motor? Steve knows how turbo help on boost also. Certainly. Yeah, he knows what's going on. Tuning a Ford 300 with Mega Squirt. Without a dyno test, what would be the best way to find the highest mechanical timing advance without knocking? You can't find that unless you have a knock sensor, because you can't. Well, you could bolt a tube to it, I guess, and listen. But otherwise, I don't. I mean, you could do it out on the street, but you start out low. Keep it safe unless you're dyno tuned. You can really get good with a distributor. Can you sell me that setup once you guys are done with the blower? I'm trying to test it at the dunes of Mexico. Big market here for resale. Which setup are you talking about, Chips? Was curious if low buck truck cam or the truck plus would be better as in performance, or your preference also, which one has a meaner chop to it. Again, I'm not going to give you which one I think is best, because you are the ultimate deciding factor for that. You decide. If that's why I steered you toward the dyno results. Do you want more power above 5,000? Do you want less power, or do you want more power below 5,000? Which one of those things is more important to you? And you decide that. There could be, if I did a poll on that, half of the guys might say above and half of them might say below. Honestly, if we did that poll, I bet it'd be 60-40 or 70-30. Most of the people would want power below because you use that more often. But that's not for everybody. You know, that's not, I have a stock motor with a stock cam in it. So that's not for everybody. But you have to decide that. You have to decide which one of those that you want more. If you want more peak power, the Truck Plus makes more power. If you want more power up to 5,000, the low buck truck makes more power. They'll both have chop to them, and it will be, the Truck Plus and the low buck truck will be comparable in chop. Hoping to keep my 5.3 stock bottom end, but can it really hold 800 wheel horsepower reliably? And I'm pushing it. No, you can. You need ring gap on it, but 800 is not going to be a problem. Would using a fuel injector with a dual cone spray pattern in an else make a big difference? No. Because the air fuel is the big thing. And then injector spray patterns and stuff are a little thing. And on your 800 horsepower deal, tune is going to be the big thing. Higher octane allows you to run more timing. For every higher octane rating, about how much timing have you been able to advance? There's not each octane point is worth this much more timing, because every combustion chamber is different, and every detonation threshold is different, because the detonation threshold isn't just octane. It's a lot of different things. I know everybody wants, well, if you go from 91 to 93, you can add 2 more degrees of timing. I know everybody wants that, but that's not reality. It's never that easy. Just Holly, if I manage the timing to shift the transmission, I don't know. Do any of the tuners have any information on that? Does it take timing away to ease the shift? I would hope that it does. Richard, if 14.7 pounds doubles your NA horsepower, does another 14 point double that number again? No, it just adds another NA amount of power to that. So if you had 300, 14.7 gives you 600. Another 14.7 just takes you to 900. It just adds another 300. Speaking of poll, we do need a poll, right? Okay, what should our poll be? No, we don't want to do that. I think actually, I think that Steve's son worked at Nelson. Worked over at Nelson Racing. Okay, do you want to see me do a test with Tom Nelson over at Nelson Racing? So we have our poll. Supercharger setup. I already sold 2 cams to local friends here from the website. That's good. Chips, what supercharger setup are you talking about? What kind of numbers were on the hidden cam numbers Steve said he was going to let you give out? I gave that out already, but I said that at the beginning. But it was a 620 lift, 223, 248 at 50, and 115 LSA. And I put that in my video. So the cam spec, that's the not so secret cam specs, are in the video already. I bought the Truck Plus. It arrived today. Put in my 5.3. I had the low buck. Bought some bigger injectors, rods, pistons. We'll see how it goes. So did you step up from the low buck truck to the Truck Plus? Or are we building a different motor and you have those cams in each one of them? Give us the fish. Quit trying to teach us to fish. No, you should learn how to fish. Fishing is very important. Trans vacuum drop equals a timing drop. The Holly can do that. I guess we don't need a pull because it's behind the scene talk. I guess you don't need a pull of what? Depends on specs for the trend setting. Yeah, and a Holly HP is not going to do that because it doesn't have trans control. But the Dominator stuff, obviously, those are linked. So I'm sure that there's something going on there. I've never worked with the trans controller stuff because on the engine dyno, we don't do that. I don't know what Blue Cat is. Mark 454, ring gap, bone stock bottom end, twin 3582s, 3-inch air-to-air, comp 280, blow through 93 pump gas, sniper HP. Guess on the horsepower? Well, those 3582s will support a lot of power. So are you running them all the way up? I mean, that's going to take you way into 4 digits. Your cam kits come do, I'm sure that's going to be do. Your cam kits come with a Cosmoline coating. They don't, I don't think, considering ordering cam, but they are wrapped up though for a build down the road. I love getting 2 hours of education. The videos from Steve. Question: what made him choose the Vortec and not a turbo? He wasn't trying to make maximum power. The guys from the same company that owns Airflow Research also owns Vortec. So I don't know why he was doing a thing with Vortec. He just said when we were talking originally on the phone, trying to schedule this all to happen so that we both could get there and do this, that he said, I have a Vortec. So I said, okay, well, good. We definitely should run boost on it, and that's fine. It's not like there was any shortage of boost there. I mean, like I said, there was turbo everything there. There were Lamborghinis, there were his SMXs and SMLs, and there was Fords and Chevys. I mean, there's everything there. So it's not like there was a shortage of turbos. But like I said, he wasn't trying to make like maximum power. He was just trying to do a test, NA and boosted. Calibration for electric trans. Okay. Just want to know so I can make the right move so it doesn't rust out when I order one. Yeah, I don't think that that's going to be an issue. You're not going to store it out in the rain and it'll be fine. I do like running the radiused air horns on stuff. And you saw from the videos, if you watch the videos, the radiused air horn, even the super double throwdown, Steve Morris with the patented swirl tube grooves or whatever. We tried running that on the, what kind of, I'm trying to remember the throttle body. It was Cletus's deal, race something. I'll think about it. Somebody let me know. But we put the raised air horn on that, and at the 600-ish power level, it didn't really show much. So there was not too much of a gain there, even though we know that that would improve the flow rate of that, because that particular throttle body, because it has a receiver groove for the flange that bolts on and an O-ring to attach it to boosted things, it has an edge there. And so that's not ideal. So eventually at some point that would become a problem. And then the radius air horn and the insert that he put in there to attach that would solve all that. But at that power level, it wasn't really a restriction on the 102 millimeter throttle body. When we put it on the blower, which I have done, and we weren't at the flow limit of the blower either, but we were getting up into the 1,000+ horsepower deal when we made that run. There was a gain in airflow going into that. I didn't check. I wish we would have. One of the things I wanted to see was the discharge temperature coming out of the blower, not necessarily into the intake manifold, which also would have been good to have both of those. In fact, I'm going to ask Steve if he has any of that data. I would have liked to have seen the inlet air temperature exiting the blower before the intercooler, just to see what happened, to see, did we change that? Because you can change that by letting the blower cool off, depending on how quickly you make the run. But I would like to have seen if angling the air horn up away from the headers has any effect on charge temperature. Because let's face it, where a blower is on almost a lot of these motors, other than the reverse rotation ones, like they first started doing for the modular Ford stuff, where the entry to the blower is facing the front of the car, then you can get kind of like Johnny Ram air going on there. Get it away from the header, because the header's not a good place to grab air. I stepped up to the Truck Plus cam. Don't know how much about motors. I have a guy building it, but was wanting to try a different cam, maybe get more out of the motor and same. Oh, yes, the same motor. Okay. I received my boost controller and valve spring tool. Everything seems good quality. I received them in a timely manner. Happy that helped, Dustin. We were back ordered on the Lobach truck cams for a while, and those are back in stock. And then I think that there might have been a supply issue maybe with springs, but I think that that's solved now too. Give us cam specs. I did. I already gave them several times. 620 lift, 223, 248, and 115 are the if you're asking for the cams for the Steve Morris thing, and those are also given in the videos that I posted today. Steve said that he would give them to me, and he did. And I said that I would post them, and I did. Tom Nelson's great. He's my third cousin twice removed. That's pretty far removed. So 97%. Yes, Tom Nelson. I like Tom. I've talked to him on the phone a couple of times. he's been really funny. I said, Tom, here's something I want to try. He goes, oh, what now? Because you come up with the weirdest stuff. Yeah, that's how we do it. And like Steve, he knows how to make power. I'd like to see if I could talk him into putting all this fancy alien and turbo technology on a junkyard motor, and then we'll, like with ring gap and stuff, and then let's just turn it up. Let's see what happens. Current camshaft is a hydraulic roller with 115. Okay. So I don't know. Are you comparing the cam that we ran to that cam, or is there? What is it? What is it? What kind of point are you trying to make? There. Is there a better selection for my cam? For what? If you're wanting a cam, what are you trying to do? What's the motor? What are you trying to do with the motor? What's the displacement? You know, what are you trying to achieve? You got to tell me all that. That's a big cam, and so you have that cam should be able to get a lot out of, as long as you're spinning it to the RPM and stuff. I have to. That's actually my son. I have to go rescue him. On that note, it is time to go. So our poll, 97 yes. That's obviously definitely yes. I'll give Tom a call tomorrow and see what's going on. Do you think a 5-feet trick flow head would be better than CNC and milled 243s? Yeah, take a look at the take a look at the Cathedral Port videos that I did. Really, really good CNC 243s will work very good. The trick flow heads also work very good. The trick flow heads are going to have thicker decks, so if you're doing boosted stuff, they're a better way to go. But CNC stuff, a 5.3 is not going to be able to take advantage of what you're going to be able to get out of ported heads. Ported heads are going to flow more than 300 CFM if they're done right, and you're not going to make a 600 horsepower NA 5.3. So there's going to be no shortage of airflow from either one of those heads. On that note, it is time to go. I'm off to rescue.